Here is a continuation of Lesson 2.6 with some additional graphing examples. Remember, when you have your basic function of x squared, and when it has something added or subtracted, when something is added to the x squared, it's a shift up, whatever the number is. So in this case, it would be up 1 unit. When it has a number subtracted from it, it's 1 unit down. Or if it was subtracting 5, it would be 5 units down. When the number is in parentheses and it's being subtracted, it's a shift right 1 unit. When the number is being added, it's a shift left. When there's a number in front of the x squared, and if it's larger than 1, then it's going to go up faster. If it's a fraction, it's going to go up slower, and this would go up half as fast. So let's try a few examples. So the first example here, notice we have a number that's being added to the x squared. We're going to compare it to the basic function of y equals x squared. So I'm going to graph the y equals x squared first, and from there we're going to shift the 3 points around the origin 3 units up. So I'm going to graph 0, 0, negative 1, 1, and 1, 1. I'm going to shift all 3 of these points 3 units up. So I'll shift the origin up, 1, 2, 3, shift the next one, 1, 2, 3, and then the next one, 1, 2, 3 on the left. Remember that this is an x squared function, so it's going to take on the U shape. The next example has a subtract 2. It's still compared to the x squared function. This time when we're subtracting 2, it's going to be a shift down of 2 units. I'm going to still graph the original, and again the order pair negative 1, 1, 0, 0, and 1, 1. I'm going to take these 3 coordinates and I'm going to shift them down 2 units. First that one, then the origin 1, 2, and then the order pair 1, 1 also will go down 2 units. And again, I will connect the points. Again, we don't want to make a straight line. Remember that it is a U shape, it's a parabola. The next example, notice that it's subtracting 2, however it's in parentheses, and when it's in parentheses, it's either a shift left or right. When it's subtracting a number, it's a shift to the right. When it's adding a number, it'll be a shift to the left. So notice this is minus 2, so it's going to be 2 units to the right. Again, I will graph the basic function, 0, 0, negative 1, 1, 1, 1, and now I will take each of those 3 points and I will shift them 2 units to the right. So first the origin, then that far left point, shift it 2 units. It's going to be on top of that one, and then finally the order pair 1, 1, shift it 2 to the right, and now connect the dots, and again make your U shape. The next one has adding 3, so this will be a shift of 3 units to the left. Again, I will graph the original, the y equals x squared. So again, negative 1, 1, 0, 0, 1, 1. I will take each one of those 3 coordinates and shift it 3 units to the left. Okay, so now I'm going to take each of the coordinates and shift them 3 units to the left. So first shift the negative 1, 1, then the origin, and then the 1, 1. I can connect the points and it forms the letter U. The next example is the absolute value function. Again, the coordinates are still the same as the parabola. It's going to be 0, 0, the -1, -1, and the 1, 1. Graph the original in blue. Notice the absolute value graph takes on the shape of the letter V. That's what makes it different from the parabola. Now notice what I'm shifting here is, again, just like when we were shifting the x squared graph, when it's inside the parentheses, but this time inside the absolute value, this is shifting the same way, left and right, and when it's outside the absolute value bars, that will be a shift either up or down. When it's adding a number, it'll be up. If it's subtracting, down. And inside the absolute value bars, when it's adding a number, that would be a shift to the left, and when it's subtracting, to the right. So for this one, I'm going to shift each one of these 3 points 3 units to the left and then 2 units up. So I'll shift the first one. I'm going to move it over 3, 1, 2, 3, and then up 2. And then repeat for the origin, left 3, 1, 2, 3, and up 2. And then lastly, the other order pair, and now we'll connect the points, and again, make the letter V. The next example is the graph of x cubed. So we will first graph the original, and then we're going to not only reflect it across the x-axis, we're also going to shift it down 2 units. So for my original, I'm going to graph the order pairs 0, 0, 1, 1, and then -1, -1. So again, we don't want to make a straight line when we connect them. It'll go up like this for the original and then down. Now we're going to take that original and we're going to reflect it across the x-axis. So my reflection will look like this. When I graph the reflection, I'll put a point here and here, and the reflection will look like this. And now, in addition to reflecting it, which is indicated by the negative sign, we're also going to shift this graph 2 units down. So the final shifted graph, I'm going to take the green points and shift them down 2 units. So 1, 2, shift down again the origin, 1, 2, and then this order pair also, 1, 2. And then again, I'm going to connect my points. Again, I don't want a straight line. It's going to go up and over and go down. So it makes it a lot easier if you just shift it. The next one, I'm going to compare this one to -3x squared. So I'll graph that first, and then after I graph that, I am going to shift it 2 units to the right and 1 unit up. Now notice the negative sign here indicates that it's going to be a reflection across the x-axis compared to our usual parabolas that look like the letter U. Now it's going to be an upside down U. But I'm going to go ahead and graph this function first, and again it's going 3 times as fast, and it's also reflected across the x-axis. Okay, so now that I've graphed this original function, now I'm going to shift it 2 units to the right and 1 unit up. So 2 and 1 up, that's our new point that's shifted from the 0, 0. Then again, I will also do these down here, 2 right and 1 up, 2 right, 1 up. And again, you can connect your points and graph your function. So So that would be the new graph that's been reflected, going 3 times as fast, 1 unit up and 2 units to the right. Our next one is a square root. So again, the basic function of y equals the square root of x, again, looks like this with an ordered pair of 0, 0, 1, 1, 4, 2. So the graph of the original looks like that. And if we first just reflect it across the x-axis, a reflection would look like this. And then not only is it being reflected, indicated by the negative sign there, we're also going to shift it 1 unit up from the reflection. So we're going to now take the green line, shift each of the points up 1 unit, giving us our new graph. The next one is also an absolute value. Here is also a graph of an absolute value. So for this one, we're going to compare it to the equation y equals negative 2/3 and then the absolute value of x. After we graph this one, we're going to shift our graph 1 unit to the right and 3 units up. So I'm going to graph first the graph of negative 2/3 absolute value of x. Notice the negative sign indicates that it's a flip or a reflection across the x-axis. So my graph will look like this. And now I will take this one and I'm going to shift it right 1 and up 3. So right 1, 1, and then 1, 2, 3. Our new point will be there. And then again, just make this 2/3 lower. And our new graph will look like that. And then one more example. Again, it's going to be the graph of, we'll compare it to the graph of the x cubed. And again, if we graph our original order pairs, again, same 0, 0, 1, 1, and over here negative 1, negative 1. Again, if we shift, we're going to shift it right 1 and up 1. So each of the new points. So right 1, up 1, right 1, up 1, right 1, up 1. And again, we'll connect our points. And again, we do not want a straight line. We want a curve to this. So our new graph will look something like that. So these are 10 additional graphing examples showing how if you know the basic graph function, and once you're either adding, subtracting, it'll shift it up or down, left or right. And if you're multiplying by a number, it'll go up faster or slower. And then negative signs in front of the x or the x cubed or x squared will indicate that it's going to be a reflection.